Hello. 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 Hello, sir. Is it audible, sir? Hello, sir. Is it audible, sir? Okay, sir. Thank you.
Hello. Hello. Okay.
ఫస్ట్ నాదే పెద్ద
Yes, yes, yes. వాళ్ళకి పర్మిషన్ ఇవ్వాలి సార్ ప్రజెంట్ చేయడానికి తీసేది
అవును. Good morning to all. Today's session will start with a lecture by Dr. M. Hema, Professor, Plant Virology, Muslim University, Tirupati. Good morning to all. Today's session will start with a lecture by Professor, Plant Virology, Muslim University, Tirupati. Good morning to all.
Hello, ma'am. Actually, the host has to disable the screen sharing. Otherwise, I'm not able to share my screen. Not able to share my screen.
Can you please check now, ma'am?
Can you check now, ma'am?
Please unmute, madam.
Then Amravati and United States India Education Foundation, Fulbright Nehru Academic and Professional Excellence Fellowship for the 2016-17, and she is having BBT Long-Term Overseas Associateship during 2009 to 2010. Has specialization in molecular characterization of plant, animal, and human viruses, elucidation of requirements for plant viral RNA replication, including RNA structures, functions, guiding recombination, repair and interaction with cellular environment, development of novel strategies for virus vaccines and diagnostics, and virus-based nanotechnology made her to publish 60 research publications in reputed national and international journals. She has completed 5 major research projects and has 1 major project ongoing. And currently, she is working on using plant virus nanoparticles for biotechnological applications. So it is apt to invite her for this session, and her topic for today is nanotechnology and its application in plant viruses from pathogens to biotechnological tools. Welcome, ma'am. The stage is open for you, ma'am.
Thank you, ma'am. Thanks for the nice introduction. Good morning to one and all. Am I audible?
Yes, ma'am.
Okay. Okay. Thank you. Thank you. Good morning, one and all. Ma'am Pushpavati, ma'am, and Reddy Bhaskar sir, good morning to you. And thank you for the opportunity. Thanks to the organizers for giving me this opportunity to speak some of our work. Actually, in this presentation, I would like to get an interesting topic actually, because which is very novel and it's not been worked out in India so much. So I thought for young minds and for young researchers, this will be a platform where I can share some of the thoughts. Actually, in this presentation, I'm going to talk about a little bit of nanotechnology and its importance as an introduction, and then I'm going to tell whether viruses can be looked at only as pathogens, or it can be useful for some of the biotechnological applications, and some of the characteristics of plant-based virus nanoparticles and virus-like particles, so that we can use them as nanoparticles and nanocarriers. And then before going to the application side, we need to check whether they're toxic or whether they're able to do any kind of hazardous thing in the body. So we checked on the animals. So that work I'm going to share. And then I want to focus on 3 applications. We are doing many other things also, but just for this talk, I would just looked at imaging application for cancer biology and drug delivery applications and diagnostics for the poultry virus. And then I would like to conclude it, and then I would just want to touch upon on some of the applications of other plant viruses which has been tried in abroad. So as for the students' sake, it's just to tell you that nanotechnology is nothing but you deal with particles which are 1 to 100 nanometers in general, where you can control the atomic and at molecular scale, and then you try to develop them and you try to modify them in such a way that they'll be useful for different applications. So when you look at the nanotechnology per se, you will have a lot of applications. So I'm going to touch upon some of the medical and health applications. And then as we see with respect to the different viruses, like I put some 2 plant viruses, 2 animal viruses, which are very important, and 2 human viruses in the slide, telling that so when we look at the viruses as such with respect to plants, animals, and human beings, we think that they are bad because of, especially after going through the pandemic situation, we feel that like we are all stalled for 2 years and we could not make progress, and every other activity has been stopped by many of the programs. So we will think that the viruses are bad and they are considered as pathogens. Of course they are, but apart from that, there is another angle of viruses which has to be looked at, and which we can make use of it for many beneficial applications, which is the topic of today's talk. So when you look at the different nanoparticles, the major advantage of nanoparticle is that it has got high surface and volume ratio, and that's why you can put a lot of drugs into it, and high payloads you can use. and then you can get it done very effectively. So that is the main purpose of nanotechnology and nanoparticles. So you look at the slide here where I have put many useful nanoparticles where people are using liposomes, polymeric nanoparticles, carbon nanotubes, fullerenes, and like many others are there, which has got a lot of different applications. And I've put it as the new nanoparticles, the natural nanoparticles, which are virus nanoparticles, are virus-like particles. So I will tell you what are those particles. So I said here it is natural building block. So it's very important because you don't have to synthesize, because naturally they are available. We just have to make use of them. So I'm going to touch upon the contrast property and the imaging property, and then targeted delivery, and of course the diagnostics also today. And then for that, we need to see what are all the different properties of the viruses has been used for making them to work as a nanocarrier or for the beneficial biotechnological applications. So first we will look at the shape of the nanoparticle viruses. Is it resound is coming? I'm just wondering. Okay. So the shapes of the viruses, if you look at it, so you see these are some of the plant viruses. You see rigid rods, and then you have flexuous rods, spherical particles, bullet form particles, pleomorphics are there, geminate particles are there. There are different shapes, but when you look at them, they're all uniform. They are monodisperse. So you don't get different sizes altogether, especially in this platforms. So that means that when you synthesize artificially, then there is no chance that you will get a monodisperse nature particles. So this is an advantage with respect to the virus particles. And then when you look at the assembly of the viruses, it is very, its architecture is very unique in such a way that, for example, if you look at the helical symmetry, you will see the rod-shaped symmetry, and then in the icosahedral symmetry, again, you will see a very particular shape here, icosahedral structure. So, for example, if you take tobacco mosaic virus, the monomers, the capsid subunits, so which will be forming 2,300 copies of monomers will form the disc initially as a disc-shaped structure, and discs will form as a helix. And then the RNA will be wound around the central groove. So this is how the helical symmetry has been made. And when you look at the icosahedral structure, so it is very unique, where you have 12 vertices, 20 triangles, and with 60 subunits. So the idea of having the icosahedron is that not to have the bigger size of the subunit, though the subunit is very small, it wants to include its genome, big genome into it, and then for that it increased the number of subunits, not increasing the size of the subunit, but it increased the number of subunits. So many viruses, if you see that 60 subunits will form the icosahedron, that is T equals to 1. But if you see T equals to 2, it is 120 subunits. T equals to 3, it is 180 subunits, like that. So when you look at that, so just now I said that instead of increasing the size of each subunit, it increased the subunits number, so that each asymmetric subunit will form into multimers, and then hexamers and pentamers, and then you will get the icosahedron structure. So the subunits can be identical or different. So when you see this example here, 2 equals to 1, so where the subunit is very identical, and it has been arranged in the form of the asymmetric subunit, and the 60 subunits will be forming the icosahedron structure. Satellite tobacco necrosis virus is the example. So in this case here, where you see the 3 subunits which are identical, but the conformation is different, so that is why it is named as A, B, C. So these asymmetric subunits again will form the pentamers and hexamers, and then it will be able to form a unique architecture, which has been very special with respect to these viruses. So I've given Sesbania mosaic virus as an example here. So apart from that, there are 2 other characteristics which we need to note down before getting into the real applications. So when you see the replication of virus, once it enters into the cell, it gets disassembled, and then it multiplies, and then gets assembled again, and then gets released. So that means that naturally it is able to disassemble and again assemble inside the cell. So this particular property has been used for the nanotechnology applications, where you can put, instead of RNA or DNA, instead of genome, you can put your drug. So, and then the virus, when it goes inside, it gets disassembled. So it will release the drug, and the cancer specific cell will be killed because of the drug. So this property is very, very unique with respect to a replication of virus. And then one has to note down this topic, this particular characteristic. So as I told you already, the viruses are natural nanoscaffolds. So where they allow chemical and genetic manipulations. So the virus genome is very small. So generally it is less than 10 kb in general. There are some viruses where you have bigger sizes also, but the genetic manipulation is simple when compared to other pathogens. And it is having the protein structure on the outside, so that you can do the chemical manipulation also by bioconjugations. And you, as I told you, that if at all, if you arrange something, it is very unique architecture. So spatial distribution will be very, very specific. And the rational design and ligand orientation, you can do all kinds of designing and stoichiometry, which is very, very special. And then to maximize the target recognition, you can do all these manipulations here through genetic and chemical engineering. And then this level of control is not possible with other inorganic and lipid nanomaterials. So that is why viruses are very, very special biotechnological tools, nanotechnological tools in that way. So natural delivery of its genome is another unique characteristic. So you don't have to do anything. Virus will, on its own, it will go inside and it will be able to take care of its function. So why plant viruses? So I'm going to focus on only plant viruses here. Because as you know that animal viruses, there are a lot of apprehensions. If you use, we don't know whether it will recombine with our genome or it will cause any kind of diseases. Nowadays, the zoonotic diseases are in big picture. So I'm not touching on any animal viruses. So plant viruses we used for some of the biotechnological applications. So I would like to highlight some of the properties of plant viral nanoparticles. Like, as I told you, they are naturally occurring nanomaterials. Size range is generally 20 to 400 nanometer that we used. And then high degree of symmetry is that just now I told you. Monodisperse nature, you see any virus particle, it is of the same size and nature. Efficient and inexpensive production, so you can get them from the plants, so it's very cheap. And biocompatible and non-infectious in mammals. So there are no reports that plant viruses will be infectious, because we all eat vegetables and which can be infected, and there is no report that that they cause some diseases. So they are non-infectious per se, but anyway we have to test anyways. And plant virus like particles, like if you see them, so if at all, if you express the coat protein inside the heterologous systems, there may be a chance that some of the viruses can make the virus like particles without any genome. So if you see it here, so where virus nanoparticle will have the genome, but virus like particle no genome, but it will be empty capsid in general. And the structure and morphology will be very similar, and that is the basis for VLP based vaccines also. And then biocompatible, non-infectious, non-hazardous, absolutely non-infectious, because there is no genome at all for replication. So as such, we cannot use any of the plant viruses directly for the nanotechnological applications, because we don't know what are the characteristics of those viruses. So we need to check in vivo fate, like inside the body, what will happen, like pharmacokinetics, blood compatibility, biodistribution, clearance, toxicity, all that we need to check before taking up to the human applications especially. And then chemical and genetic modifications, you need to make sure to see the biocompatibility, solubility, and high uptake efficiency. So where you can manipulate the charge, shape and size, and the shielding also you can do. See, people will be thinking that if at all, if you take the nanoparticle, then the system can recognize as an antigen and it can elicit some immune response. So you can shield virus nanoparticles so that with PEG or some other molecules, and you can put any specific ligand so that you can target them also to the specific cancer cells. So these are all possibilities that, but that means that you have to do some kind of functionalization on the virus particles, then only they'll be able to function for the specific application.
కరెక్ట్ వేరువా మేము నీతో పాటే వచ్చినాం
Excuse me. Hello.
ఇక్కడ చూసినాం నేను మాకు నీకు
Am I audible?
Yeah, we can proceed now.
Yeah. Okay. Thank you. So if at all, if you want to look at the modifications, how you can do with respect to the virus particles to make them as nano carriers. So you can do genetic engineering where you can go for agro inoculations to do the modifications in your genome and then agro inoculate it and do the agro infection. Or you can do, because it is a protein structure on the surface, so you can do modifications through bioconjugation. So use different chemistries and attach some of the ligands or molecules on top of the viruses. Or you can do infusion, because these assembled particles are not completely closed. They have small pores where you can use the cargo, that is drug molecules, so that they can go inside and stay there only because of the electrostatic interactions. So some of the people, they have tried metal precursors also, where it has been decorated on the surface as well as inside. And self-assembly is another program where you can see disassemble the viruses outside, that is in vitro, and then again put the cargo and then assemble them. So there are certain viruses they can disassemble outside and then they can be assembled, and then you can put the cargo inside. So these are some of the methodologies that you can use. And then this is a slide where it has been shown the different chemistries. So we may not be able to understand completely, but it is the message is that you can do a lot of modifications on the viruses by using some of these chemical reactions based on the amino acids that are available on the surface. Okay. So like that, people have tried. They have tried to put oligonucleotides, antibodies, drugs, fluorophores, carbohydrates, targeted proteins, peptides, gold. So all kinds of modifications has been done in abroad laboratories. So the viruses which are being used, Brome mosaic virus, copy chlorotic motile virus, copy mosaic virus, and there are two other viruses, and then some of the bacteriophages also has been used. So rod-shaped viruses, people used potato virus X and tobacco mosaic virus. But before we start this work, there are no reports from India. So with that intention, we got a DBT project, major project. With that, we started this work a couple of years ago, and then we got some progress and some leads with respect to that, which I'm going to share. So how do we produce the virus nanoparticles? We need to infect the plants and then purify from them and do some of the modifications, as I said just now, and evaluate them in vitro as well as in vivo. So you need to see before going for any kind of human application. You have to test them. Though you say that plant viruses are non-infectious, you need to test them in the animals. So this biodistribution and toxicity studies, we have done it. So for that, we selected Sesbania mosaic virus. Sesbania, you know, it is a fodder crop. So there is a virus which infects that, which is very stable, which has got T equals to 3 particle symmetry, and then icosahedral symmetry, 30 nanometer size, very stable. And then we know that the coat protein can be expressed and the VLPs can be recovered. And then the crystal structure is completely known. So we know which amino acid is present where. So that's how we get into this. And then we try to purify them. So this is the light scattering zone in the sucrose density gradients. So we injected different concentrations into the mice. So these are the mice experiments. So this is a study which is showing that how long the virus is present inside the body. So we try to administer very high concentrations. So in the fecal matter, we see up to 6 to 16 hours. So after that, we could not see in the fecal matters. So, and then it has been degraded by 16th hour and not observed after the time points. So then this is a RT-PCR assay where it has been performed with respect to the blood, and we could able to see the ACMB presence from 1 to 72 hours, both oral and intravenous injections. And this is RT-PCR analysis of RNA, total RNA, which was extracted from the liver and spleen, where presence of ACMB has been shown from 6 hours to 72 hours. And then this is the histology studies where sections of the brain, kidney, liver, lungs, spleen has been done, and then there are no symptoms of any tissue degradation or necrosis, which is telling that it is not toxic. And some of the biochemical characterization that we have done, some of the enzymes, serum creatinine, and some of the important blood proteins, all that indicated that there is normal kidney and liver functions are there with respect to the biochemical analysis. So these are all different proofs that there is normal liver function, there is no oxidative stress. Some of the lipid peroxidation enzymes also we checked in different organs, like glucose 6-phosphate dehydrogenase, and there are many other things. So which is telling that there is normal metabolism is there after the SCMV introduction. So this, just to conclude this work, biodistribution and toxicity evaluation studies of SCMV in mice indicated that it is a safe and non-toxic platform to develop as a nanocarrier. So with that lead, we went ahead and used this for imaging application. So we tried to label the SCMV particles with Alexa fluorophore. And then when we saw with respect to the HeLa cell lines, these are cancer cell lines. So when we observed it, the SCMV is able to enter into the HeLa cells in we did the cell imaging also in 5 minutes it could enter, but to see in the confocal microscopy, so you see that 1 hour, 2 hours, 3 hours, it is been increasing, and it is able to enter, plant virus is able to enter the cancer cells without any problem. So these are HeLa cells, these are HepG2 cells, so different cancer cells, liver carcinoma cells. So here also you see major SCMV is inside the cancer cells. So then we try to look at the cells which are infected with SCMV, and when it is being degraded, so we see that there is a degradation of virus is happening after a few hours. So that has been depicted through the Western blot. Then we want to see which is the host membrane protein which is allowing this virus, how it is interacting with that. So we found that through LCMS, we found that there is vimentin protein, this is far Western analysis. We found that there is a vimentin protein which is present in the HeLa cell line which is interacting with the virus, and there are some other proteins also. We could be able to detect it through LCMS. So just to summarize this, it is internalizing into all kinds of mammalian cells. We tested many cells. I shared only two cells, and then it is using vimentin and other proteins for internalization. So all these days we were thinking that plant viruses will not infect the human beings or will not go into the human beings, but that's not true. Plant viruses know how to enter into the human cells. So how do we make use of it for different applications? That is up to us. So then we selected another platform, which is a virus-like particle. As I told you, this is an extinct virus. We don't have it in our country. So we selected this virus because it has been worked out, and again, crystal structure is known, and the code protein has been expressed, and it is forming the VLPs. So all this information is already available. So we just took this platform. So code protein gene has been expressed in the bacterial system. So when the code protein subunits are able to expressed, when they're formed inside the E. coli, they could able to form the virus-like particle. So this has been known already. So we took this platform. Then this is the expression profile of PHMV code protein in the bacterial cell, and then you see that the code protein also can be purified. The VLPs can be purified. Light scattering zone is very evident, and it is been assembled particles. And then the pure protein has been shown in the page gel, and FTLC is showing the single peak that it is a single polypeptide, and then transmission electron microscopy. So any type of modification that you do onto the virus particle, you need to characterize them and show. Okay, so then we used lysines for chemistry, and then we tried to put again fluorophores. So because of the lack of time, I will just quickly go through the message I will try to convey properly. So again, characterized functionalized particles has been shown that they are sound, they are intact. With the modification, there is nothing happened. The dye is still inside, all that is evident. And then we try to take different cell lines. So different cancer cell lines altogether, and we saw that the PHMB VLP is also going happily inside the cancerous cells. So these are again bone marrow cells, and then prostate cancer cells like HeLa, HepG2, and this is breast cancer, and like that many cell lines we have taken. And interestingly, in the normal cells, the virus is not going as much, and the bone cancer also it could not go, but all other cells it is going very well. Okay, so this is FACS analysis again as an indication that the VLPs are indeed going inside. And then we try to look at that what is happening with these VLPs when they go inside. So we found that when we try to use the LAMP antibody, we see that they are undergoing the phagocytosis and they undergo the degradation, which is that we want actually. So then we used for drug delivery, and then we try to use some of the cargo molecules like DOX is a anti-cancerous drug, and then we used PS photosensitive agent also. So we try to use infusion technique here, and then we characterized again the functionalized particles. They're all good. And then we used for this photosensitive therapy. That means that if at all, if there is a melanoma patient, wherever the cancerous growth is there on the skin, you can target this PS PHMB where it is working very well as in PS alone. And then this cytotoxicity study is also telling that they're working as good as the PS alone. So the PHMB is acting as very good nano carrier. And then we try to put the DOX. DOX is an anti-cancerous drug, and then the PHMB DOX also is working very well. This is a study with 2 different cancer cell lines, cytotoxic study with the cell lines, and then it is also showing that it is working equally well like DOX. Then we try to test the stability of these particles. So up till 3 months, these particles are very stable. There are no problems at all, which is a good indication that they can be a strong nano carrier. And then we try to put the gadolinium here for using as a MRI agent. And then we try to see that the PHMB is going inside the tumor, and then it is staying for almost 240 hours, and which is very good. We try to use prostate cancer 3 model here. So just to summarize that the PHMB and SEMB are going inside the human cancer cell lines, and then we can able to target the cells by using the anti-cancer drugs, and then they can be used as both for cancer therapy as well as MRI agents in vivo. And then diagnostic quickly, just to tell you that the infectious bursal disease virus is a poultry virus, very important virus. And then what we did was, I'll try to explain the important strategy here. So we try to take the IBDV neutralizing epitopes and we try to display them onto the plant virus particle, that is PHMB. So we try to fuse them at the N terminus, and then we try to display them and produce them the chimeric VLPs. And we developed the lateral flow assay, which is a spot assay, a point of care test. And then we try to develop dot immunobinding assay by using this recombinant proteins, and then we could able to detect the infection and then antibody levels. So this is very important strategy that we took up, and it has been published in very good journal also. So just to conclude the work that the infection related epitopes of animal virus, that is poultry virus, has been displayed onto the plant virus, and then the LFIA and DIBA has been developed, and PHMB is working as very good imaging agent, and then it has been used for drug delivery applications also. So just to give you last 2-3 slides, other applications, like if at all, if you see that gold particles, if you arrange on the plant virus, how the architecture of the virus has been shown here. So it has been arranged so well. The stoichiometry and rational design, this kind of arrangement you will not see with any other nanoparticles. So this is again cowpea mosaic virus, others work where they have used for imaging application. And then this is also one application here. So where they used directly as for in situ vaccine. So there is a tumor here. They injected virus-like particles of CPMB, and they found that that is completely gone here. So you see tumor in the control, but here the tumor has gone because of the ECPMB is attracting all the immune cells to the place, and they're acting on that, and they're trying to clear the thing. And this is again a tobacco mosaic virus where phenanthroplatin is a drug again used for the cancer here. And it has been loaded into the TMB particles as a capsule, and they could able to get the reduction of tumor here. So then this is also DOX CPMB where people used and try to kill the cancer cells. So these are also, this is another interesting application for the plant pathologist. So this is a tobacco mild green mosaic virus, which is very less virulent to the plants. So they use this because this is also belongs to the tobacco genus. So they use this and try to put nematicide inside, and they try to apply for the soil. and then they got this paralysis of this nematodes, and then they could able to get the plant growing very well. It has been published also. And then I just want to conclude my talk with that, saying that the small meets the big. So there are a lot of potential with respect to plant viruses where we can use for multiple applications, and the technology has been spreading its wings, and people are using for many different applications altogether. And I would like to thank all the organizing committee for giving me this wonderful opportunity. I would like to thank all the participants for patient listening, and I would like to thank the rapporteurs and the chairman and co-chairman for giving me this opportunity. Thank you so much. I would like to answer any questions, if at all, if you have. So these are the collaborators for this work and my PhD students who finished and doing very well in their career. And that's my department in Venkateshwara University, Department of Virology, those who don't know about it. And thank you so much. Is there any question that I would like to ask me?
Thank you, Dr. Hema Madam. You have clearly given the virus usage not only as plant pathogen, how important it is in the nanotechnology for many medical and agricultural aspects. So thank you very much for your elaborate lecture on the important aspect now. I request the audience for any queries.
Madam, this is Dr. Jagdish Kumar. So it has given a very beautiful lecture on implications of viruses and nanotubes. Here you have given, Madam, the viral nanoparticles and the virus-like particles. So regarding the virus-like particles, there won't be any genome, like the DNA or RNA. Isn't it, Madam?
Yes, there won't be any genome for replication. Actually, virus-like particles are generally empty, but some of the virus-like particles, they can code for this mRNA alone. But anyway, it's not complete genome, so they don't replicate.
Yes, madam. This is how we can integrate drug into the genome, madam. So if it doesn't have. And it's only made up of proteins.
Yes. Yes, and if at all, if you are putting any target onto it, like if you are putting any ligand or an antibody, you can use the specific technique which can be recognizing that particular ligand.
Yes.
See, all that what you want is whether you are whatever you are going to add, whether it is there on the top or not, right? That is the fundamental thing. Just detection of virus-like particles is not going to help. Whatever molecule that you are going to put on top of it, so you need to know that they are on top, right? Because in the transmission electron microscopy, you will not be able to see it. So based on the properties of the molecule that you are going to put on top, see, now we are going to try to put some of the enzymes on top of the virus particles. So that is another project that I am handling now. So where we want to put the enzymes on top of it so that we can use it for immobilization of enzymes. So then we will try to see the substrates we will take, and then we will see that whether enzymes are decorated on the top of viruses or not. Okay, hope I answered your question. Okay.
It's a very novel type of work, madam. And you have been carrying all the kinds of the viruses as being used the nanotubes. And here, madam, so why there is more emphasis on plant viruses? Why not the human viruses making
human viruses? If you want to try, then there is a question that for human applications, there is a question that it can be infectious. Yes, so for other applications, for biophysical and biochemical applications, for industrial use, of course you can use. But again, problem is for example, some of the viruses can transmit through air. So those viruses you cannot even touch. So because of all that implications, we just took the plant viruses as a beginning platform.
Yes, madam. So in that case, even now we have seen that the COVID-19 situation, so where the vaccine is developed using the mild form of the strain. So why can't it be tried?
Pardon me, sir, I'm not able to hear you properly.
Yes, madam. So here, as we witnessed in COVID-19 situation and its vaccine development by some of the councils, so where the mild form of the strains used for as a vaccine.
Yes.
So why not the case with this?
Uh,
Why can't we try?
why can't we try
Yes.
plant viruses? Is it? That's what your question is?
Yes.
Okay, so actually we thought about it, but you know, for doing any kind of COVID related research, we need to have a BSL-3 facility. To conduct research in on COVID-19, we need to have BSL-3 facility. We don't have a facility here, but now I am part of the BSL-3 facility, which has been permitted in the ISAT Tirupati. So probably in future, we will be able to take up that area of research also. Thank you.
Thank you very much, madam, for you have carried a very fascinating work in step, and it is of recent importance. And thank you very much, madam.
Thank you. Thank you so much, sir. Thanks for the encouragement. Thank you, ma'am.
Thank you, ma'am. That's a wonderful lecture, and I hope the budding scientists will definitely look after into this area of research. Now, Dr. Jagdishwar, Director of Research, is online. So his topic is unmanned aerial vehicles as wings of smart agriculture. In this area, now definitely this is a very important topic, and ma'am, Hema ma'am.
Yes, yes, yes.
Would you unshare your screen, please?
Yes, yes, ma. I'm not able to hear you.
Can you unshare your screen, ma'am?
Yes, yes, please. I will do that. Sorry, I will do that.
Good morning, Jagdish sir. Are you online, sir?
Yeah.
Dr. Jagdish sir is currently working as Director of Research at Professor Jayashankar Telangana State Agricultural University, and is a dynamic personality who is working on standard operating procedures for these unmanned aerial vehicles on different crops. He is presenting us on the topic unmanned aerial vehicles and means of smart agriculture today. So the stage is open for you now.
Esteemed chair and co-chair and rapporteurs of this session, I am audible? Am I audible?
Yes, sir.
Esteemed chair and co-chair and rapporteurs of this session, and distinguished delegates and senior faculty members, and my dear students, ladies and gentlemen, very good morning to one and all. At the outset, I convey my sincere thanks to the organizers for giving me this opportunity to share some of the thoughts on the new emerging topic, particularly the unmanned aerial vehicles as a smart wings of agriculture. So this is the main purpose of this topic, is to share some of the research work that has been carried out at this PJTSU, and also I would like to take your inputs in formulating the future research work in the use of the unmanned aerial vehicles, particularly for different agriculture operations. So keeping this in view, I am presenting this topic. This is the flow of my presentation, wherein I am going to give brief introduction about the scope and use of the unmanned vehicles in agriculture for various activities, and also the genesis of the drone application and the research work that has been carried out at this PJT centers. And particularly, we have concentrated in the last 2 years on the spraying, developing the standard operating protocols for the in different crops, and also crop monitoring to some extent, and also now we are deeply involved in the crop area estimation for the as per the mandate given by the government of Telangana. And we have developed the standard operating protocols for the 5 major crops, particularly the rice, cotton, soybean, and also to some extent in groundnut, and also in other crops now we are working out. And another important aspect is, and with the concerted efforts and all the support from the government, now the PJTs is going to establish a PJTs Drone Academy. The main use here is to create a platform and the facility for giving the capacity building programs and also organizing the certification courses for the benefit of different stakeholders. And also we have done some use cases to showcasing the technologies that have been we have tried during the last 2 years. And finally, I'm going to give some of the issues and also the challenges that we have come across during the last 2 years of this research program. Now, as you all well aware that as per the FAO 2020 report, now the usage of the drones in, if you see this under industrial is about 42%, then if you see this in agriculture, it is only 19%. But tremendously now it has been steadily increasing in even in agriculture also. And insurance is 15%. And in case of real estate, to making the marking of the other things, that is about 22%. And in the governmental schemes, that is about 2%. But if you see the agriculture drone market, that is by 2025, it is going to be reach by about $5.7 billion US. So that is the impetus, that is the impact that is we are going to see. And similarly, in the next, the Indian agriculture drone market, if you see now, it is steadily increasing from 2018, and it is going to be, as per the estimated report given by the Blue Wave Consulting, which is going to be steadily going to be increased. So there is a need to, as a plant protection group, there is a need to develop a lot of scope for us in promoting this drone technology. And there is an in-depth studies need to be done on various aspects. So that is the concern now. And if you see the scope now, what at PJTs now we're mainly interested, and these are the areas we have selected. The first one is crop monitoring. So, and also the second one is particularly this is very, very useful for the identification and also the pest and disease issues, and also the survey, particularly wherever this some of the issues now we are recently encountering, particularly the black thrips or the sometimes in some of the places where BLB is in an endemic, particularly in Nizamabad and other districts. So now where we are trying to map with the help of the NRSC and also with the government of Telangana and also IT department. And the most important aspect now for the last 2 seasons, we are working for the developing the SOPs for spraying technology. And also recently we also taken a decision to use this, particularly the nutrient application of the using of this. And another important is, since now labor is a major constraint in many of the places, particularly in the villages, where the sowing and also the seeding is a major issue. So for which we have also come up, we have made some efforts in this direction. And recently we have developed a applicator, particularly dry direct seeding and also wet direct seeding, where we can use this type of technology. And we have made some attempts in also developed in collaboration with the Maruti Drones Private Limited. And now we have also filed patent application with the IP department. Similarly, there is a scope for the ultra high dimension pest scouting. This is one of the most challenging subject, and there is an in-depth studies need to be done. So this is the area now we are prioritizing. And another important is, since as you all well aware that now the most of the areas, now the irrigation potential have been tremendously increased, and the government is insisting to map the entire area from the existing 2014, and now the tremendous area has been increased in the irrigation potential. And also now the one of the most important aspect is the variety identification. This is very, very useful, particularly in case of paddy, where we are getting a lot of issues with the procurement policy. So in order to identify whether this is a variety is a fine grain or medium slender or short bold or like that, and particularly as far as the market is concerned, whether it's a grade A or common. So this is one of the most important, so that we can arrive at what type of yields we are going to get in a given season, whether it is Kharif or Rabi. That will help the marketing department to make all the arrangements for the procurement without any hindrance. Another important, as I already rightly pointed out, that the irrigation potential has been increased. Now the government is insisting us to map the entire area. So what is its implications? In some of the areas with cultivation of the rice in Kharif and Rabi, that will be creating a lot of issues. So what needs to be done for the with respect to the irrigation management? So these are the areas that have been selected. This is the scope for the use, and there are a lot more scope for the, especially for the usage of the drones in the near future. So as you coming to this, so spraying is one of the important aspects that we have selected for doing this. And these are some of the major important advantages, where many of the, as you are well aware that with the drones, we can go for quick and easy and highly efficient as compared to the conventional methods, where we can have a lot of time and laborious, and also it is a very tedious effort for the operator to, particularly in the paddy fields and other crops, where in commercial crops also it is becoming very problematic. And also there is a, with respect to the safety to the operator, particularly there will be no exposure or minimal operational exposure will be there as compared to the conventional method. And with regard to the usage of the water, particularly we require about maximum, we require about 15 to 50 liters, but still this is per hectare, but still there is a lot of work need to be done to standardize the requirement of the water depending upon the crops and also depending upon the phenophase of the crop. So that is a most important aspect, and particularly as compared to the about 500 liters in case of conventional method. And the most important is the precision of the spray is most advantageous with this usage of the drones, and also that will take care for the uniform coverage as compared to, and this will be much more useful for the large scale areas and also crop areas. And similarly, in case of sudden outbreak of any pest and disease, then this would be the best option as compared to the, wherein we can, particularly in cotton, now we are getting a lot of issues with the black thrips, and also in case of some of the alternaria leaf blight, and also particularly the tomato spotted wilt virus. So these are some of the major issues where the farmers could not able to take a, particularly in the chilies and also in case of cotton and other commercial crops. So where this can be used as a for monitoring as well as also for on customizing basis. Also now the government is insisting to develop this technology, and also it is also in inaccessible areas also we can able to reach without any hindrance. And as compared to the, and we can have, by use of the drones, there will be better return of investment as compared to the where in conventional method will time and also the amount need to be spent is much more cumbersome for the farming community. And this is the just I'm summing up. This is the drone spraying technology that is a 2.5. It's cost effective as compared to the conventional method, and it is a 16 times more labor efficient as compared to the conventional method, and 8 times more time saving similarly as compared to the conventional method. And as per the requirement also is we can save about 12.5 times. That is a water saving is also there. Then finally, this is a better return on investment as compared to the conventional method of the spraying. And just now discussed about the difficulties, particularly with the manual spraying. So many of the times the farmers and also the labor who are going for spraying in the manual method, these are the hard to work, and also the exposure to different molecules, particularly if you take propanophos or some of the these are very inhalation toxicity is much more severe, and also they are prone to many of the diseases, particularly the nerve disease and other things. So they are not able to identify at the initial stage, but later on they are realizing the problems associated with the exposure to these molecules. Similarly, most of the times now there is a farmers now, because of the urbanization, many of the times it's a very problem in getting up the labor. And as our given this is a precise and efficient and safe. So with this, now we can have improved pest management and also crop productivity. And finally, we can able to go for the sufficient quantities of the food production that is required for the country, and also from the nutritional aspect also we can enrich the growth of the in different phenotypes of the crop. So this is the chronological order that where the different activities have been taken up at the PJTSU. So first we have initiated this activity in 2019 for mapping of the and also distillation of the university properties, particularly the farmlands. So now we are equipped, and we can even, this is one of the most important aspects. So for all the agriculture university or state agriculture university, so wherever you are working, this the mapping is most important. So nowadays, most of the people, they are grabbing the land, particularly the university land. So now at regular interval, we are running at every 3 months or 1.5 months as and when required, and we can able to assess so which point now they are grabbing, so that can be easily we can detect out and we can protect out. This is one of the most important aspect. Now the government is insisting, and they have given directions that the entire all the farmlands, particularly the government these things they have to map invariably with the drone mapping. So second one is we have initiated the research and assessing of what is the quantity of spray fluid required for aerial spraying with that. That is one initiative we have taken up, and now I'm going to give that results also in the next few slides. And recently we have also initiated a network mode, the evaluation performance of drone aerial spraying, and as compared to the ground-based or knapsack or this Taiwan sprayer, or for the this has been initiated in the first 2019 with the safflower aphids. And now my colleague Sudhakar will be going to discuss with you in the later on with the giving the details and later in our course of this symposium. And we also organized one brainstorming session on the drone-based application in agriculture at the University of Tirupati for the different, by involving the different industry people and also the representatives from the input agencies and also the IIT and also their NGO organizations for the to take their opinion, because many of the times we are getting a lot of queries with respect to the this usage of the drones, particularly the NGOs. So to clarify their queries also we have invited them. And recently in 2020 we have signed an MOU between the PJTs and also aviation department and Madras Institute of Technology, Anna University. So to have collaboration on this usage of drones, and we are taking a lot of inputs from them for the developing the SOPs and also crop health monitoring and also crop estimation and also other aspects for the using of the drones in collaboration with the National Remote Sensing Agency. And also we have also launched a network project on evaluation and standardization, and for which we have selected during last 2 seasons we have selected about 5 crops, and now we are further going Rabi crops also, particularly the maize and Bengal gram. Now the area has been tremendously increasing, and we are also exploring the possibility in developing the SOPs. And also we also signed a MOU between PJT and the various drone companies, particularly the Maruti drones and also Thanos. So where we are supporting them in providing the necessary technical, particularly in the agriculture domain, the usage of the chemicals and their phytotoxin, etc. And also as our just discussed with you, so we have also developed an applicator for the dry direct seeding or wet direct seeding. In this direction, we have developed this, and we have filed the patent also. Provisional patent has been made, and during the November 2021. And these are the crops where at Rajnagar we are working for rice, and at Warangal for cotton, and at Jagital soybean, and Tandur red gram, and at Palem groundnut, and also Jagital sesame. And these are the areas that have been earmarked for the different centers, and also we are collating the data and also giving the results, and we have completed the 2 years data. And not only the research centers, we are also at farmers will also in large scale area, we are also taking this methodology for evaluating at the field level and also giving apprising the farming community. So they are also made awareness on the usage of the drones in different crops. So these are the outcomes of the results. Particularly, these are the 7 crops we have tried. So with respect to the spraying height, water volume, and also drone speed, and also nozzle type, these are the tentative results, or we have received the confirmative results for the last, that is 4 seasons. That means about 2 years data. And this data we also submitted to the DGCA and also the task force committee that has been given from the government of India, and wherein these are the spraying height. If you see, this is varying from 2 meters to 3 meters, particularly depending upon the crop. So still there is a lot of scope. So how best we can work out on this. So this is a tentative spraying height we have decided, and also these are the confirmatory results have been received during the last 2 years. And similarly with the water volume. So there is a lot of debate is going on this thing, how much water is required. So many of the people, they are restricting only for 10 liters or 12 liters or 15 liters. But there is a need to be, lot of work need to be done. And as far as the 2 years results are concerned, it is varying from 10 to 16 liters per hectare per acre. So this is the water volume that is required. So another thing is, the most important is the speed, at what speed we have to run the drone. So this is one of the most important aspect, where lot of intricacies have been involved, particularly with respect to the pollination and other things. So drone speed is one of the most important aspect. So now this is about coming about 2.8 to 5.5 so meters per second. Now this is the nozzle types. We have evaluated different nozzles. Out of this, for crop wise also, we have made which nozzle is very useful, and that will enhance the efficacy of any molecule, and also the best type of nozzle that we can select. So these are the type of nozzles also we have worked out, and many of the times we have also worked out at 1x dose and also 2x doses for the different pesticides. So at present 1x dose is sufficient for to getting the good results. So these are the preliminary results that have been established, and also we have submitted to the DGCA and also the other government agencies for their verification. And we also invited some of the stakeholders, particularly for the government of India, and also the NABARD was kind enough, particularly our alumni, Dr. Chintala, ex-NABARD chairman Chintala Govindaraju, was kind enough to provide the sufficient funds for the developing the technologies, and also they are giving a lot of support for the government of Telangana and also PJTSU in developing these SOPs. And also he has visited. And also we are in collaboration with the World Economic Forum. We are going for the crop health monitoring and also crop estimation. And recently the secretary, particularly the Manoj Javia, was very much fascinated, and also he was kind enough to see all the problems that are involved, and also the particularly the capacity building programs, and also the development of the manuals. And also he has in depth, he has gone to the SOPs that has been developed, and in recent and shortly they are going to give the projects to the respective state agriculture university, and also they have given the subsidy for the subsidizing the use of the drones for the different farmer producing organizations and also KVKs. So based on the last 2 years data, we have also generated the data, and also we have released the booklet during the Indian Agriculture University session by the Honorable Vice Chancellor and also the Principal Secretary Raghunandan Rao Garu, and also the Chairman for the IAU. So this is booklet is, I request my colleague Kiran will be there. He will be going to share that document to you for the benefit of the all the participants who are here gathered here in this symposium. And recently we also initiated the Drone Academy, PJT's Drone Academy. The main aim of this academy is to provide the training or capacity building programs to the different stakeholders. They include the industry people and also the rural youth, and also the identified people by the Department of Agriculture, and also the district collectors, for where young youth will be trained, and wherein we are going to deliver the the basics of the drone, and also the rules, what are the rules, particularly the digital rules, and also CABRC, what are the regulations, and also Ministry of Agriculture. And these guidelines will be given. And we are also going for a training and mapping of the usage of drones, and also drone flying and spraying technologies, and also the manual and autonomous flying also. These are the where we can educate the students, and so that based on that we can issue the license to the different stakeholders. And similarly, there are also how best we can make the obstacles, and also the how best we can minimize the while operating the drone, because there are a lot of technologies involved in operating this drone, so these need to be done. And there are certain challenges need to be addressed, so that I'll be going to put forth in the last slide, where we can need to work together. So particularly as a plant protection group, it is our responsibility to address these challenges. So as for the PGS Drone Academy, so far we have 4 faculty members have been master trainers, then they were certified by the DGCA. So this is one of the important aspect for all the state agriculture universities to get master trainers from these, so that they can able to give and deliver the particularly with the understanding with the minimum for the capacity building programs. So recently we have signed for RPTO, the remote pilot training organization, on 12th October. And also we have done the documentation, complete documentation, and we are ready to upload it on with the consent from the principal secretary. And also we have developed as per the mandate given by the DGCA, we have also developed the curriculum for the different stakeholders with respect to the usage of the drones, particularly for spraying and also other activities. And I am going to discuss in few slides about the use cases, particularly the AI for AI, this artificial intelligence for agriculture innovation in Telangana. This is the one project given where to address the problems, particularly the accurate real time, the crop and variety area estimation. This is one of the important challenge aspect. And similarly, the how best we can reduce the time lag in data management. So there is a lot of many of the software tools, they are well versed, but they don't know how to correlate with the data that is going to be after giving the image processing and other things. And also the early warning and diagnosis also, so that they can able to, we can relate with the weather data and we can give the early forewarning also. And also the most important aspect is where the harvest windows plays a major role. So that can be useful for the marketing department to place all the arrangements for the procurement and other things. So similarly, the outside we are also facing the data. So in most of the times we are getting data is a major constraint. So there is a need to have uniform data formats, and also the frequency and all these things will arise. So from also perspective of the different stakeholders, farmers and extension officers, so I have listed out these are the problems. So we could able to resolve with this use case with the World Economic Forum and also IT Department of Telangana. So the most important is the artificial intelligence and science-based solutions. So where we can use the remote sensing data and also drone, and also this IoT LRA networking also, that we can use this program, and also with the technology inputs for the AI algorithms for crop development and also auto generation, particularly NDY, and also these are very helpful in managing, but still there is a lot of scope and there is a need to evolve this programs for this whatever we have discussed. And but there are also in the certain challenges also we have faced, particularly with the geofence and the agri data. So and also poor access to accurate resolution data. These are some of the issues where we are approaching the NRS and also NBS LUP Nagpur for getting to resolve these issues. So another use case is the varietal identification. So we have just tested in 3 districts, Nagar Karnool, Karimnagar and Nizamabad, where in cotton crop we have taken about the overlaying points about 112. At the same time, we have also gone for ground truth data also. So these are the results indicate that the overall accuracy of the, by using this drones and also with the ground truth data, the usage of the drones can classify the varietal identification, provided the characteristics of that photographs and also given variety need to be uploaded, and then we can, with the using of this classifier, that can give an accuracy of the 89%, and as well as the variety is concerned, particularly we have tried with KNM 118 and RNR 15048, and it is given about 82% in case of KNM 118 and also 94% accuracy in case of 15048. So this all depends upon the how best we can map them, and also we can ground truth data so that we can compare the results. So that drones definitely going to be very useful for identification, marital identification, that will thereby we can recommend to the government. So these are the marketing arrivals, these are the harvesting window we can propose. So based on the duration also. So this will be very useful. And but provided this requires a lot of input, particularly in the form of the imagery. And similarly for the disease diagnosis and also breast diagnosis, many of the people are there coming, but they don't have any libraries, maximum number of libraries, because the symptoms also varies with different stages of the crop. So as much as libraries are required to map and also diagnose at right stage and right time. So this is the recently we have signed an MOU between the Maruti Drones Private Limited in establishing this RPTO. So and this is the one magazine where we can get a lot of information about the drone technologies. So I request all the participants who are here. So this is the one magazine where we can get a lot of information, so that you can refer. So the whatever you can publish on the or generate the data and you can publish in this drones world where you can get a lot of information. And similarly, there are issues at the adoption level and also accessibility and affordability. So these are the issues that have been propped up during our last 2 years and data. So these need to be a big problem, and this need to be resolved at different levels. So for which a fine tuning needs to be done at different levels. So this is coming to the last slide, that is challenges and way forward. So particularly many of the challenges, when we are interacting with the farmers, the initial cost of the drone is very high. So it is costing about 7 to 12 lakhs. So depending upon the, and one more thing is, if you can able to arrange, and particularly the SMA, particularly the small submission on agriculture mechanization. So wherein the government would like to have introduce the customizing centers for the way of giving the deliverables through the drones, and also the cross-specific drones for spraying pesticides. So already we have developed, and the general SOPs have been developed, and we also submitted to the task force committee, and now they are at pursuit. And similarly, the compatibility of the pesticides for this already with the government has given the particular the CA base for about more than 477 pesticides for drone basis. So that is the most important aspect one should be kept in mind while using the drones for spraying. And similarly, the adaptability of the farmers, now the government is for which we are taking up large scale demonstration with the support of the drone manufacturers, and also with the support of the T-Hub, where the empaneled members are there for providing the service for the drones. Similarly, lack of skill related and operation services. So for this, we are established with the help of the ASK and also NABARD, and also the support of the RKWay. Now we are going to establish and exploring the funds for the different activities for the usage of drones through the RPTO and also for different activities. And another important challenge is limited use of hours, where because most of the time they are going for battery operated one, and there is a lot of and other spare parts. So that is the most important. So where we can able to there is a scope, particularly this look out for the other people, private vendors, where instead of battery, where there are any opportunities, we can explore. This is one challenging issue, need to be way forward, that need to be understood. And similarly, the customizing centers, as I already discussed, the submission on agriculture mechanization as providing this in future, going to establish customizing centers for the drone operators, particularly the unidentified or the identified from the different districts. So these are some of the issues I would like to place for the thinking in this direction. So I'm very much thankful to the organizer for giving me this opportunity to share some of my thoughts and also the views on the recent research activity that has been initiated at PJTC. So I request all of you kindly, if there are any queries and questions, please let me know. Thank you very much. And my special thanks to Kiran and also all the organizers, particularly Rakesh Pandaji and other colleagues. And also my thanks to Sharada Madam and also Reddy Kumar for chairing the session. Thank you.
Sir, thank you very much, Dr. Jagdish, sir. Given the picture of drone, the latest technology, useful for smart agriculture and important day of the important event of the day. Thank you very much, sir, for covering all the aspects of drone and agriculture.
Thank you, madam. Thank you.
Sir, thank you very much, sir, for your elaborate and concerted efforts that gateway agriculture for the application of drones. University Vice Chancellor, Honorable so laying much emphasis on drone technology in diversified areas of agriculture. And in order to tide over the problems which are being faced with other partners. And so you have given a very elaborate information as far as the application of the drones. But as far as the ground level, so as you have mentioned, the different issues and the challenges that are being faced with the partners. So it is the well said that with major drawback lies with the drones as of now is the process. Should be cost effective so that it should reach to the farmers. So because lot many farmers they are unable to purchase. So that's the major problem have faced farmer level. So that has to be addressed. And so as you have given its application, sir, how best the varieties could be identified with the drones? So could you elaborate please on that? Variety identification using drones.
Reddy Kumar, I am unable to hear properly. There was no clarity. But anyhow, my friend will be there. Sudhakar and also Kiran will be there to give your reply. So I am unable to hear the clear voice from you.
No problem, sir. You have given very elaborate information, sir. What are the challenges, issues that are being faced? Thank you very much for your elaborate information.
Thank you. Thank you.
Sir, are you audible? Am I audible to you? I have few queries to ask you. Hello? Jagdish sir, is it audible?
Yeah, you are audible, but I could not able to hear properly the clear voice. There is some problem. Kiran, are you there?
Yes, sir. Sir, as you mentioned, like there are no trainings and subsidies that are available to the farmers, then how it will be, how the farmers will be able to use it properly?
Kiran, are you there? Kindly respond to that question.
Yes,
I would like to answer that question. Now, any other question?
I'm just trying to know what is the launch of the drone. How many years?
So regarding this training part, as you know that in India is around 90 drone pilot training organizations are available right now. But when we see this fee structure also, that's why the ANDO is also working on, PDB is also working on that. The fee structure is around 50 pilot training. How can a rural youth come and get the training for that one? Easily buy it the 6 to 10 lakhs drone. So in that context also, there is a dire need or requirement for establishing a drone academy by agriculture ministry. You see that every drone training requires a domain-specific drone academy required. I can go any drone academy for getting a pilot as a pilot because I am as a master trainer. So I got trained at 7 or 10 days at Hyderabad. But I don't know how to. I just know how to fly the drone. But I don't know how you can use an agriculture. So in that context, it's still progress. There are so many academies are coming in India. So that overall for you, the 10th class graduate, how we can make a different. I mean, basically, it needs a special maintenance. So regarding the longevity is 3 to 5 years. 3 to 5 years, but they can use up to 6, 7 years also based on their maintenance. But battery longevity is only 350 to 500 lifetime. This is about the longevity. Thank you.
Thank you, Dr. Tirupati.
Thank you, madam. Thank you. Thank you.
Thank you very much, sir. I hope in the coming seasons, we will be utilizing the drones in the field of agriculture a lot more in all the crops with the research findings of all the delegates present here.
Thank you. Thank you. Thank you.
Now we'll move on to the next topic, that is role of gene editing technologies to enhance plant disease resistance by Dr. Ishwar Ramareddy sir of Indian Institute of Science, Education and Research, Tirupati. A brief introduction about him. He did his PhD from Germany and he is a recipient of DSP Sir Early Career Research Award and also a recipient of Young Research Scientist Award from Solo Foundation, Berlin, and he has also received grant from Elsa Newman grant for graduate studies, and he is working in ISO Tirupati since 2016, and I'm sure his talk will be very much useful for the young budding scientists over here. The stage is open for you, sir.
Good morning, everyone. If you don't mind, may I ask you, those who are interested to listen to come forward because those slides are not visible. And then I must say that particularly for participants, students, and scientists over here, you are not understanding that some of the talks organized by this organizing committee or from the stalwarts of this field. And then it's really heartening to see that the response, the way that people are not even here in the second day itself, it shows that, whether our participation, because the quest of knowledge that what we came over here and others, it is not good. We already heard, I think I don't want to go again and again what we are going to do, and then we are talking about industrial agriculture revolution 4 or in terms of revolution. We all know that what are the goals. Every one of us knows that why we need to do. We need to increase more crop per crop, and then we want to have more nutritional security rather than just increasing the food grains. And we also know that there are different ways of. Yesterday we heard about it, detection and diagnostics, in order to identify early itself and early stages itself how we are identifying that, because it has an immense potential in reducing the loss that we are going to do. So what are the technologies that are available for us in order to reach that goal? Some of them are genomic and precision breeding, like genome editing technologies. Other one is sensing technologies. Just now we heard about it, how using drones and others, one can able to see that even varietal selection that they pointed out, it is possibility. And then more and more we are using agri-informatics, I call as AI, artificial intelligence and machine learning, over here. And together, like we need to come out of the domain-specific knowledge in a transdisciplinary manner. We should not, like I'm a plant pathologist, so I will only look into pathology. No, we should gain knowledge across the field, and then we try to integrate all this knowledge into the answering a particular question. So that's how one need to address. And then today's talk I will confine to this gene editing technologies, why and then how. Basically, these two brings more precision and then again the speed or time. So what makes the precision is coming? Whatever you heard about CRISPR, and then this is more precise than our traditional mutational breeding, which we normally use for in order to make transgenic, in order to make resistant plants or tolerant. However, the other thing is a new sequencing technology. Just yesterday, you heard about Phyto sequencing technology, how it can be used to rapidly diagnose. Similarly, this high-throughput sequencing technology can also now know to help you to identify sequencing technique, to identify varietal program and even barcoding, even whatnot. Many things which we are going to do it much cheaper price than what we normally use it for anything. For example, you're now able to sequence an entire genome of a newly variety of something in a matter of 1 lakh rupees. Done. We have all the entire genome is available. Before that, we don't have any genome information. We keep on working for like, okay, this no genome information is not there, and then what kind of markers we should use, how the marker information we can get. It is now possible. You just spend a bit of time and then it is a possibility. And again, when you want to go inside gene delivery methods, we always depends on agrobacterium, or we can also particle bombardment, ballistic gun. But right now, people are using nanomaterials and others, which are even possibility to go even more time and then genotype independent. Because we do have a bit of problem with what kind of agrobacteria goes, what kind of plant, and then there are agrobacterium recalcitrant. So the transformation is not working. But now we can use carbon nanotubes in order to go them like directly genotype independent transformation is a possibility. So technology is growing like changing so fast. We need to catch it up in order to address these questions. So just for the students' purpose, briefly introduce what is CRISPR. It's again coming from the pathologist, away from bacteriologists, the word itself, because how bacteria is trying to put its immune system, that we understand, and then that understanding turn into a technology, how it is happening. So if you see over here, whenever bacteria are infected by the bacteriophages like viruses, they release their DNA or RNA nucleic acids over there. And then what bacteria does is, it has its own molecular sigils called Cas proteins. There are several of its kind. So some of them, like Cas1 and Cas2, they recognize this one. And then they go and cut a small piece of the viral DNA. So that viral DNA, what they do is they integrate it into a CRISPR array. What is the CRISPR array is? Clustered palindromic repeated sequence. So at least here you can see that there are repeated units in its own genome. And then here, whenever a new viruses or new DNA, foreign DNA coming into this, it's trying to cut those and then going to put it over here. So this is in this space, so they are going to put it over there. Now once over here it is happening, this one is going to transcribe, and then we will get a CRISPR RNA, and this CRISPR RNA is going to make a complex with the Cas9 protein. These together
this CRISPR RNA and Cas9 protein together form a surveillance complex. So next time when a virus infected, share. Here, new share and share and green button. In the green button, there was a file on drawing. So this form, I'm sorry for those who are in online and then unable to hear me for the first few minutes, but at least you might have more information from the my talk or talk rather than the slide. So if I look back into the presentation itself, like right now, so these ones, whenever this foreign DNA come into it, bacterial Cas9 proteins cut into it and put it into this CRISPR array. You can see all those spaces over here. These are all foreign DNA materials. These are going to be transcribed into CRISPR RNA. This CRISPR RNA then combined into or loaded into the Cas9 protein. They become like a surveillance complex. Now, next time when the similar kind of bacteria was again reinfected, it's immediately identified this one, go and match it. So it will go and match it and then immediately going to break into small pieces. Like interference mechanism that has been going to work and then it's going to be. So this is how this is bacteria are going to get an immunity, how the immunity system is working in bacteria. So the next question will come like, if they are going to be already, when the bacteria is infected over here, the same thing can also be there over here in the space also. Why not bacteria, I mean this surveillance complex, not going to bind over here and then degrade it? How it is maintained it's, so that it is not self-degrading its own CRISPR RNA. So that the quick license is, whenever they cut initially, they always cut in a place where they have a palm recognition sequences. So adjacent to that one, there is having a 3 nucleotide sequences very specific to the foreign DNA, not to the repeats of what is having in CRISPR. Because of this palm recognition sequence over there, next time when it is coming the other bacteriophage, it identifies the palm recognition sequences and then cut it. Whereas when it binds you over here, that palm recognition sequence is not there. It is followed by the repeats. So that's why it is not able to cut its own CRISPR or its own DNA genome, but only the foreign gene. Right? It is as simple as that. So how scientists use this one, that knowledge, into a technology. So instead of bacteria was giving it, and the same thing that RNA, that what we are talking about, or RNA or DNA nucleotide sequences, we are providing from the external. So for example, if you want to target any particular sequence, that particular sequence you are making as a guide RNA or a cRNA, and that one you are going to make it custom designed as cRNA. You are providing into the bacteria and put it into it. That is going to combine into the Cas9 protein, that becomes a surveillance complex. So whenever it is directly going to the nucleus, like when you are transform it into the system, they go to the genome and then there exactly goes and binds to it, and then it cuts a double-stranded breaks. So because of this double-stranded breaks, and then there is a possibility that a gene is going to be lost, or gene is going to be mutated because it can cause indels or making insertions and deletions, but it can also cause promoter disruptions. So there are several examples that have been already there, not in just in pathology related, but in general also. Several plant species that has been already genome edited has been done majorly in rice and tomato and then other things. So it is a possibility now we can create even within the promoter also we are going to do. So the best example maybe for the audience purpose we use the example of pathology, not the other side. So in science that we have bacterial pathogens, fungal pathogens, and viral pathogens. So
what are the avenues that where we can use this technology so that we can engineer plants such a way that they can be more tolerant towards this infection. So what we can do? What we can do is we know that there are some known resistant genes, R genes are there. And then we also know that in some varieties, these R genes are present. And then we also know that in breeding, we always use for the SNPs, right? So this SNP is there, and because of that, that is resistant, where those which are lacking the other varieties, those are susceptible. Now you can recreate that kind of SNP into an R gene of the susceptible one. So by changing that particular one by using base editor, SNP is a single nucleotide, right? That single nucleotide can be incorporated over here so that you can again make that susceptible genotype into a resistant. The other thing is, we also know that when a pathogen is infected, there are several susceptibility genes are there. And then these susceptibility genes, pathogen is trying to regulate its expression. Because of this regulation, it is trying to survive in the particular cell. So if we already know what are those susceptibility genes, one way of doing is you can remove those susceptibility genes from this one by cutting them. Then the moment you remove our susceptibility genes, what happens? The pathogen which is surviving in the host does not have any support from the host. When it doesn't have any support from the host, eventually it will die. I will give you one small example of that. And other thing is, you can also make insertions. Insertion means, for example, the same thing, it is not a single nucleotide SNP, but it is having like entire R gene is missing in particular genotype. What you can do is in the homology directed repair mechanism, you provide a template of R gene, and then the other one which is not containing R gene, in that same locus, you can again completely switch it. So you make the whole R gene over there, which is important for that. It can also do that. You can also make an insertion. And the last thing is you can also edit a promoter. So promoter is important, for example, particularly in the bacterial system. Bacteria produce factory secreted proteins. These are tailends you can see from the umicities and levels. So they goes and binds to the promoter region and activate some of the transcription factors or genes which are necessary for their survival. Now, if you know that where these are all the tailends, for example, in case of tailends, they always goes and binds to a particular binding element on a promoter region. Because of that particular binding, the transcription is activated. Now, imagine you remove that particular binding element. Even though the tailends are coming over there, it cannot able to bind to it. So it cannot able to make a transcription of a gene that is responsible, but such as susceptibility gene. Then again, you can get it. Or we have also gene knockout for another case where you can also completely remove a particular gene instead of making fine details like changing a base pair, removing a particular part or something. You can completely remove. That is also possible. In other cases, in viruses and others, you can also directly either use it for the diagnostic purpose. You can directly target to a particular virus. So RNA interference, normally they are using it for viruses and others. It's a possibility, right? Same thing is the concept. So sorry whether it is visibility or not. So what is important over here it is, the first thing is, if you all see that you need to identify the susceptibility genes or the genes from the host side who are helping the plant pathogens, whether it is nematodes, fungi, umicities, bacteria, and virus, who are helping those pathogens to gain or to sustain its life cycle in the host. So when you look at it, when from the pathogen establishment to the pathogen regulation to the immunity, there are different stages of these pathogens which is critical sometimes. For example, if you take Magnaporta variety, which is causing mass disease, the important thing or the critical phase is when it is on the surfaces, it has to make an adhesion and then has to bind to it. If those pathogenic strains which are unable to make this kind of binding so stronger and then make a penetration effect inside, right? With the melatonin higher concentration, that melatonin causes pressure, that pressure causes effect formation inside in order to puncture it. Imagine that melatonin is not there and that's not there, then it is not going to cause any disease at all. Similarly, the moment it's working inside it, and then it produces an effector proteins. Now, these effector proteins, most of the time, what happens is they try to detect it by the plants and then make a PTI,
patent immunity. Sometimes these are on unnoticed, and then they can be causing diseases. Now, if you understand what is they are going to do, and then whether this is going to be recognized by it or activating that, then you can easily do either multiple at a time, so several things, or allele, like already discussed. One classic example is one bacteria, one virus I can tell you is, which has been done, shown several crop species is, yesterday you might have heard about Professor Santi's talk, bacterial like Xanthomonas. And then Xanthomonas variety is working on, right? And this Xanthomonas variety, what it does is, it's a bacteria, and once it is infected into the plants, it's also required sugars. So the cell where it is infected, it goes and activates the sweet transporters, like sweet 11, sweet 13 transporters into the cell. So that activate it, and plants think that, okay, this particular cell requires sugars, and then this transporter brings the sugars from the neighboring cell into this one. And then that sugars will helpful for the bacteria to reproduce furthermore. So how it does is, it produces the tail and factors from this one, and then they go and bind this binding element on the promoters of the cell. Now, because of that, the sugars will come into the cell, they will increase in the large number. What we can do now is, if you remove that binding element over there, now the tail factors are also came into inside, or the effect of it came inside, they cannot bind to it. When they cannot bind to it, they cannot make the sweet transporter to activate. When sweet transporters are not activated, sugars from the neighboring cell is not going to be transported. When there is no sugars, nothing, then bacteria cannot survive much longer without food. In this way, they already engineered plants which can be very resistant to the provided resistance to the leaf bacterial leaf. The other one is, most of the time, viruses. The viruses, when they infected it, what they do is they require, you also know that, right? Viruses always hijack the translational machinery of the core system, and then make the several copies of its own protein. So one of the ways that how they do it is they bind to the eukaryotic elongation factor 4. And then this eukaryotic elongation factor 4, then if you have it over here, and then they make it entire thing, produce its own subcomponents, either protein and all this. Now imagine that you have a mutation over there in the elongation factor 4, and that one cannot able to bind by the viral genome, then it cannot hijack the translational machinery of the host. So far, the natural resistance that we occurred in virus, several of them is having a find mutations on the elongation factor 4. Now people are able to recreate the same thing, and then it is possibility that you can get a viral resistance. This is easily helpful in case of virus. So one classic example is, I think you might have heard Professor Hema from National University, and what I'm doing with Professor Hema and Dr. Madhuri from IIHR is, we are working on 3 model viruses. So she might have worked in full-length infection clone and others. What we know is, Professor Tushar and from Madhuri lab already identified there are several resistant, completely immune and susceptible genotypes over there. So first and foremost important thing over here it is, I will keep on repeating it, susceptibility genes. Identification of the susceptibility genes. One of them is elongation factor, known one. One can target the known one and then make the susceptible one into a tolerant one. Another way of doing it is, you take it those resistant susceptibility ones, and then you employ different types of omics like transcriptomics, metabolomics, or proteomics, and then identify what exactly is happening upon infection of this cellular material. Different time period, what is happening, how plant is responding, how pathogen is there, and then you identify the genes that are responsible for it. The moment you know that those genes you can create networks and others, and after all these things you get an identified candidate gene, then you can edit it however you want, either at the promoter level, either at the gene level. You can edit them, again bring the resistance. So this is the way one can do it when you know how to do innate susceptibility. Now, there is above ground part, and then I just want to go the below ground part. As you all know that soil-borne pathogens are a menace to the crop system. And then most of the time it is very difficult in the soil-borne pathogen, either when you spray indiscriminate use of fungicides and others into the soil, it's sometimes again counterproductive, because on one hand we are making
killing the non-targeted plant pathogenic promoting bacteria and also spoiling the soil health and all this. However, many a times when we know that when a soil-borne pathogen is infected, we will came very late because the symptoms that are visible later on, with the wilt or whatever, it comes later to us. By the time we realize it, we can't do much. And the research communication or whatever happening in the below ground is very difficult to access it because it's always happening below ground. But what we know now is that communication that is happening in the rhizospheric environment in the below ground is very crucial for plant health. If you are maintaining a very good root system or a very healthy root system, I would say, then the plant is becoming healthy. So how you are maintaining a healthy root system? Because it is already surrounded by the several growth promoting bacteria, growth promoting microorganisms, and also pathogenic causing microorganisms. And then how they communicate each other. And then, so if you first need to understand how a particular microorganism trying to enter into the system. It's born into the soil because spores and others are germinated and favorable conditions are there. Those germinated ones and then have to enter into the host system. So here in the soil means solely available organ is roots. And then how they are going to change into the enter into the host system. Some of the microorganisms, either it is fungi or it is bacteria, what they do is they produce hormones like molecule from the phytohormones, plant hormones, and then the plant thinks that okay, this is their own hormones and then respond accordingly. By this way, they change the plant, they trick the plant. So in considering that they produce more number of lateral roots or more number of changing the root system architecture such a way that it gains entry into. So the moment it's enter, once it is enter inside, then it can be, sometimes it can be biotroph for some time, then it is more in number, and then eventually it can become in necrotroph. We know that, right? Those will be biotroph and others that are happening. In all these events, what is important is how it is able to enter into the plant root system, how it is manipulate the root system, how it is communicating with the plant in order to do that. So first we have to know how the plants in general have normally modulate the root system architecture. We already know that plant hormone cytokine plays a very important role in the lateral root architecture or primary root melanocyte. And then I did several years ago, like different increasing the root system architecture in different crop, barley, maize, brassica, apples, and other things. We show that an optimized root system architecture is really helpful for the drought conditions, nutrient poor conditions, and also for biofortification and phytoconjugation. Several of these things is possible. However, because now we know that how a plant can engineer a root system architecture according to different components. Now, when we want to apply that knowledge towards to the plant pathogen interactions, so what I should know is how this communication is happening in the below ground, how pathogen is trying to get entry into the root system. Within the root system, there are different kinds of cells and tissues, which are the targets of this. And then in the end, what is how they are going to get. Like I said, all this required not just a approach like from direction, we require a transdisciplinary approach. We need to study a particular question. For example, my question is the communication and the entry of these ones. So in order to understand these ones, I need to follow a different ways of approach, not just bringing all system level approach or system biology level approach to tackle this. So I just give you a small example of how we did it in case of one pathogen such as that. And then I can also give you an example of one from the host side, another from pathogen side. We work on both sides, not only the host, we are also working pathogen. So we all know that blast disease is causing magna proteorhizae in cereals, and then it is like several genes are, some genes are identified like PA54 and others which are causing kind of an R genes. So we thought in spite of knowing all these things, why we still don't have it, and then we, like I said, that with the genome editing technology, whether we can do anything over here. So the first thing is whether we can able to identify any susceptibility genes for this pathogenesis. Now, if you look into the literature, there are several people have been done this kind of transcriptomic studies or proteomic studies of one infection, what is happening, how many genes are regulated or down regulated, then giving susceptibility resistant genotypes, then done it.
So we asked ourselves a question like, okay, there are several data sets that are available in different kinds of hosts like rice, wheat, and different kinds of tissues like leaf, stem, and then roots because magnaporta can also root borne and soil borne, right? And then we have different kinds of platforms, RNA-seq, microarray platforms, and others. We take the raw data of all these things and then analyze ourselves and ask our question, irrespective of the host, irrespective of the tissue, irrespective of the pathogenic strain, because some of them are from Japan, some of them are from China, some are from India. In all these things, whether we can find any common genes that can be regulated upon infection. So that's the idea that we want to see that. And then we came across when we have 16 data sets that we have done, we see that there are some genes which are, like I said, that in all these conditions, even in this condition also, out of 16 data sets, there are some genes which are nearly 10 data sets, they behave very similarly. That means either they are upregulated or downregulated, indicating that whether you are having, whether you are doing anything, these might be, genes are very important. These are not related to the race specific, these are not related to the genotype specific, but these are the genes that might be necessary for the pathogenesis or necessary for the disease resistance into the host, so they are regulated. So we take those kind of genes. The next level is, okay, we have this kind of set of genes, very few of them, and then we want to see that whether it is really happening there or not. So what we did is, we take nearly 5 susceptible, non-susceptible blast disease genotypes, non-tolerance blast genotypes over here. And then we went to collect the field samples in different areas like Martiru and then Nellore area registration, Tirupati, in vitro conditions in IARA in Hyderabad. We collect all areas. We collect into 2 different years, in 2 different seasons, total 4 kind of things, and then we collect all this material. Then we did a validation by qPCR. We want to know that we identify a particular gene. For example, you can see over here, PPT 5204 is a susceptible for blast, well-known susceptibility genes, and TETUP is a known for a check for blood disease. Now we can see some of the genes, for example, this OS-MAC transcription factor is highly upregulated in a susceptibility one, but the resistance one is not upregulated in it, similar to CDR9 or this one. So these are the things. Now, what it does mean, the pathogen is infected in a susceptibility, a particular gene is highly regulated. Just go back to that sweet transporter analogy that I gave. Now, in the tolerant one, that particular one is not upregulated. That means pathogen required this particular transcription factors need to be expressed in order to get more susceptibility action. That means more. So now what will happen if I remove that particular transcription factors using a CRISPR edition? Then there is a possibility that I can engineer blast disease resistance in this, right? So this is the way, like we have several candidate genes which are up or down regulated, which are differentially regulated, which are validated not only from the field control experiment but also from the field lab. So we didn't stop there because we want to know that this is magnablast. This is not just for rice. It is now becoming very nice for the finger millet and also for the basra too. Millet and all. So what we want to do is, and then we did ourselves a comparative transcriptomic study between a resistant and a susceptible variety of the finger millet. We did a transcriptomic analysis. We have up and downhill regulators. This is like normal thing. So what we did is we compare when these genes that are up and down regulated from the ragi and from the wheat, from the rice, and then we thought, is there any conserved gene that has been behave very similarly across these 3? These are all cereals. Then when we gave them INA for the infection, is there any gene that can be completely down regulated among these 3 or upregulated among these 3, indicating that that gene function is a kind of a conserved during the pathogenesis. So like that, we are looking for those conserved factors and then see that what exactly it means. Whether is there a way that we can use that particular one to engineer. So this is another thing that we are working on. So coming from the host side, no, pathogen side, that is all we are here from the host side. The pathogen side is, we all know that we are working on fungal pathogens, and we all know that within a species also, right? Some are pathogenic strains, some are non-pathogenic strains. And then within the fluid, there are in one Mycota, there are several of them are there. Some of them are pathogenic, some of them are non-pathogenic. So we first ask this question: what makes them? What are the entities or gene entities or others or genetic makeup that makes them to decide this is a pathogenic, this is non-pathogenic? Whether from the sequence information itself, whether we can able to segregate them or separate them. So what we did is we take roughly around 21 non-pathogenic, 20 pathogenic strains information that has been already available. Entire protein information is available over there, and then we segregated them because it is Mycota or Mycota, and let's see what is happening. And then we did with in silico analysis with the help of a bioinformatician in our group in as a Tirupati and one of my people students. We did kind of a secretome analysis of all these pathogens, because secretomes, these are the necessary ones to establish communication, to establish pathogenicity in the host, right? And then from the secretome, then we see that what is there any biological process, any protein that are differentiated between pathogenic and non-pathogenic. And then we also went ahead, what are those proteins? Whether these are all kind of intrinsically disorder proteins. That means the protein, it is not in fully conformational changes, it is because we always think that the protein when it is going into three-dimensional structure, then it is a functional. But however, when protein is in a nascent protein status, that is intrinsically disorder protein, that is also have a function. So and then these functions are more easy because it has more flexibility to it. Once it is in a conformational changes, either the ligand side or binding side, it is a kind of fixed. But when it is non-conformant state, it has a more flexibility where it is binding, how it is binding. So several of times, for particularly these kind of dynamic interactions, normally they are trying to work with this kind of intrinsically disorder proteins. We then understand what is those proteins that are there, which are separating to non-pathogen to the pathogen. So we identified those kind of things, and then we are creating a loss of function mutants in those. Particularly, I'm working on Fusarium, loss of function mutants in the Fusarium marxiscorum, and I see that whether this one is a virulence factor or this one makes the difference. It is like that. We are working on it. We have some more time. Then I said that root, and then what kind of root cell type that is important in order to gain entry into it. And recently we are compiled an article like how a single cell RNA can help for us in deciphering gene regulatory network, particularly in the root cap. So why root cap? Root cap is the organ that you all know that it is the first organ or tissue, let's say, that it is going to touch into the rhizosphere, and then it is involved in different tropic responses. They are not just gravitropic responses, but now it can also form differently nucleotropism, hydrotropism, and then halotropism, they all cases. And then in our classic example, this root cap or the slower root cap cells containing the molecules are very helpful for the communication to the microbial world. So that's how we are interested about we want to know how exactly this root cap plays an important role, either in communication or in the providing resistance to the pathogens that we can contact. So for that purpose, what you require is first you need to know what are the proteins that are present in the root caps, very specifically. So if you want to know how what are the proteins are there, first you need to understand what are the proteins that are present only in these root cap cells. Then upon given infection, if you give an infection or you give any kind of a stress condition, then you see what these proteins does, with whom they are interacting. Then you will know, from there you will detect how it is going to be done. So for that purpose, what is required is you need to have a cell type specific promoters, which are very specifically expressed only in the root cap, which is polymerase later root cap. And then you are using fats or some kind of a thing where you can digest it. You can make several. So what you do is you are having a lot of roughly around 8,000 or 15,000 CG, and then you cut it 0.5 mm, 0.5 roughly below 1 centimeter tips or something like that. And then you cut those ones and you digest them in the protoblast. And then these are all sorted with the facts. Those which are GFP positive, that means root cap cells alone. Those which are GFP negative or rest of the cell types in the root. Now, of these ones, when you collected it from this many large scale, then you identified what are the proteins that are present in that root cap cells alone compared to the non-root cap cells at that time period. Now, you gave a kind of an infection or you gave a kind of a treatment. We gave a salt treatment, we gave a patent treatment, we gave rhizoctonia solani or Physarum oxysporum and asked the question, what is happening over there in the root cap, whether the root cap protein changes and whether it makes any kind of monitoring. So we came across a specific group of proteins went from this analysis are expressed very specifically in the root cap. These are nothing but Jacqueline associated lectins. And then these lectins from our data they came, then these lectins, and then we see that why these lectins. Then when you look at it, several QTLs that are governing both biotic and abiotic tolerance in the rice and wheat and others, they all these lectins are co-localized in the same area, indicating that these might be the candidate genes under those PTO that are governing it. For example, the non-salt or PTO for salt tolerance is also governed by candidates, one of the candidate genes is the lectin. And then lectins provided a broad spectrum resistance to several pathogens. So we thought like, okay, now lectins known for this biotic stress tolerance and abiotic stress. Now we have a root cap specific proteins. Let's see what they does. The first question we ask is whether they are really root cap specific. And then when we look at the promoter reporter lines from those ones, from starting from the germination onward, from invasion onward, the expression of these lectins are expressing there, indicating the root capsules of root tips, indicating that their presence, their activation is necessary during the germination time of the cell. Then that we can confirm it. And further, we have several reporter lines, several lectins that have been known like this one. Afterwards, then we see that, okay, these lectins are really specific to the root cap. We prove it. Then what we did is we try to express them in the bacterial system. We want to study the protein. And then we are never able to succeed. Then we change the different combination of the tags and others, make them more soluble. So all these things, so that it is not going to intrude in bodies and others. Still, we are not able to do that. Then we realize it, maybe it is an antibacterial activity, and then we can show that if indeed when you express them and then during ability control, you can see that the proteins are expressing it. It is already bacteria is equal to 1 or 10 minus 2 dilute itself. There is no growth. Whereas in the non-expressive condition, you can see the growth and change in solution. You can quantify that. You can clearly see that the moment bacteria are trying to express this protein, the bacterial cells are dying. Then we did also, we grow Physarum oxysporum and then we make a protein expressed from the tobacco transiently. That protein we put it over here. And then the moment when you put it over there, the growth of these ones is inhibition zone. You can clearly see that is there, indicating that these lectins, root cap specific lectins have antibacterial and antifungal activities. Then we asked ourselves the question, if that is the case, specifically in a particular response, for example, in Physarum and during an infection, what happened to that particular lectin expression? You see over here, upon infection, the expression of in control both of them. Upon infection, what happened is that joint country, that lectin promoter is going to be reduced. So less, not at all. They're indicating that when pathogen trying to enter into the system, it is down regulating these lectins, indicating that pathogen doesn't like this particular lectin, so it is down regulating. Right. And that it also says the same thing story with the Rhizoctonia solani, another soil-borne pathogen. And when we infect the Rhizoctonia solani also, the same thing is happening in some of them. We see in a higher infection. That means previously in Physarum, it is down regulating the lectin, whereas in the Rhizoctonia solani, it is up regulating the lectin. You see an opposite, again different. Then we see that we want to try to see whether what is the case. Like when we want to try right now, what we are doing is we have further result over there for the time sake and not continuing it. Rather, what we did is these pathogens and they try to enter into the system. They try to increase lateral root members. The moment Physarum oxysporum is trying to infect it, then what the first thing the plant responds we can see is the plant makes more number of metabolisms. And Rhizoctonia solani also does the same thing. Then we ask ourselves why plant is making more number of metabolisms. Then it has been known that the lateral root tips are becoming entry points for the mycelium spores and also for the other bacteria. So that means whether this behavior that increase the lateral root number upon infection is due to the pathogen mediated response or plant host, that is plant trying to do this one. So we try to understand this one using the mutants and then see whether we do not have it. And then we make a constitutive overexpression of this particular lectin and then see whether there will become a tolerance or not. In the constitutive overexpression of this one, this behavior of increasing lateral root number is not there compared to the wild type ones, indicating that when you have a tolerance, the host does not provide more number of entry points. The moment when you are not providing more number of entry points, then it is not able to sustain. In addition, it is also increasing its PTA response, which can be easily quantified by quantification of the RAS production and also antioxidant ability of these ones. So what we do right now is we look into these kind of lectins in tomato, we identify them, and then we also quantify, like in taking from in silico data where and how, what kind of responses they are regulated. We have a candidate gene now. We are transforming it in tomato. This particular one, particularly for rhizophonia saline and fusarium meal, to see in real scenario when we take the susceptible varieties such as Pusa ruby is a susceptible one. PKM is also susceptible one for this one, and then we try to do that. The next question, the final slide, what we are doing is we are going to the microfluidic setup in order to understand that exudates, what we are talking about. Very specifically, when I give a particular pathogen, how the root is respond. So let us say lateral root number, but other thing is root also produce different kinds of metabolites. So how do we know that? Very specific, because in soil it is very difficult. Can you play the video, please? Click on that. Below there is a come out of the screen. The minimum come out of the screen. And go back to the slide. So the play video will come here. Sorry, it's not possible. What we are doing is we are making a live imaging of it the moment we are providing a particular spores of a pathogen and how root is growing, and then later we are going to collect the exudate from it and then directly, and then when we go for DCMS, then we identify the specific metabolites that are producing. One is from a susceptible one, another one is from a tolerant one, and then see whether the pathogens are trying to get, and plants are trying to get resistant by producing a specific kind of metabolites. So this is what we are doing it, and then so our whole idea in future is like we want to make put this single cell transcriptomic data that we have already generated, and then also putting into a cell-type specific responses to particular bacteria or fungal pathogen, particularly soil-borne ones. And then we did our cell-based transcriptomic and protein infections and all this information together to try to understand how exactly they communicate, how exactly they manipulate, then how exactly plant is reiterate back. So this is an area that we are right now looking in. Thank you very much. And then for Tirupati and all funding models and collaborators. Thank you.
Thank you very much for the excellent role of gene editing technologies to enhance and medicine. Thank you very much because we have covered all the basic aspects of physical technology and proteins and all these very relevant for us because we are plant pathogen scientists. Where we will be working with all these important pathogens like flowers and soil-borne pathogens. We are very much fortunate to have you. Thank you all.
Any questions? Nothing is understood. Did you get anything?
Thank you. And various aspects covering technologies that non-transgenic approach over the problems that are associated with plants. So do we have any kind of strategies popularize this technology?
Right now, not because gene editing technology are becoming deregulated only like 3 months ago. The Department of Biotechnology agreed, and then DA's approval committee says that CRISPR edited is not a CL1 even particularly not comes under regulatory DBT regulation. That this itself is notified only 2 months ago. So then now there are several people in India who are already had working and who already developed sort of thing identified by the genome editing. So now they need to look into the SOPs of this in order to release it. What are the SOPs that need to become before, and then I'm sure in maybe next couple of years we will see a lot of crop varieties that are into the gene edited ones.
So actually, there comes between when it comes to CRISPR-Cas, that is the bacteriophages, as we are dealing with bacteriophages, and its behavior would be different under what we can say the environmental conditions. Say it as energy phase and electrical phase, and bacteriophage infect bacteria undergo energy cycle or it will go analytical phase and the temperature. So how best we could get over this kind of aberrant?
No, I think what we see is we are talking about what exactly the pathogen is, how it's going to be controlled over there. But I explained this in the context of what exactly happening in case of when the recognition like immunity is working, and then how we are utilizing that knowledge that how bacteria is trying to defend itself from the causes, and then that knowledge into a kind of a working together all other approaches.
Thank you very much.
When it enters into the plant system, it impacts the elongation factor. So you want to get resistance, you have to target the elongation factor. So actually the elongation.
Not entirely. That binding site where these are going to bind it. If you can target that particular, otherwise what will happen is elongation factor you already know that it is necessary for the host also. Then the host translation machinery also going to be disrupted. And along with this elongation factor, what we are talking about 4E, there is also isoforms. So isoforms are also available. So we are targeting one of them, but that is also not entirely removing it, not creating a complete null allele. We are creating a non-functional allele by targeting the binding site where.
In the case of challenge, whether we are targeting the promoter region. If the promoter region which we are targeting, the downstream even the sugars are required for the plant. There is any change in the promoter sequence.
So what happened is here the sugar transporter activity is going to be more only in the infected cells. Right? In the balance that is over there, and then it is not going to be when we are mutated over there. So when the talents are coming. So your question is what will happen in other places where this particular sugars are. So sugars are transported, maybe there are several others. These are all functionally redundant. There are several genes that are already transporting it. So we are targeting those which are all targeted by the talents. So the 3 transporters themselves are roughly around 10 more than 10. And then this one is targeting particular in BLB in case it is 11 and 30. Remaining sugar transported is not even targeting also. So that's why plant is also not compromised on their own.
Whenever we are with RARS. Always we have to select individual where we have only the family with the
Yes.
flexibility.
There is always a term specificity, always determined by the Cas protein that you are using. Each Cas protein has a different kind of specificity. So whether you are using Cas9 or you are using Cas12, you are using Cas11, Cas19, everything has its own. Now people are developed such a way that you are having a broad range of sequences available. So before it is 10 GG for Cas9, now we can also have even further. That makes us to find out this SCRNA within specific. Before we are kind of limited over there, but now that is also not a limitation anymore. We have different varieties of the possible.
When there is a cesarean infection, the listing level has been
Hmm.
that for cesarean, mainly we are recommending the biocontrol. When the biocontrol agent we are applying, whether that time the listing level is
Yeah, I think we are using trichoderma, I guess, for biocontrol agent for the cesarean. And then one of the things that we want to see that in this tripartite interaction, like when cesarean and then trichoderma, if both are there, how the plant is responding, what is happening at the molecular level, and then what is happening at the visual level, like architectural changes. And when individually and put together, what is happening, and then from there we try to understand how this is going to control this, and then whether in this process, whether these lectins are anything, or whether trichoderma per se increases the lectin expression in order to defend it. We don't know, but that is the one thing that we want to try to see. Thank you.
Thank you, sir.
What? Yeah, the final slide that I mentioned, that we want to collect those root exudates and then want to analyze the metabolites upon infection. So for that purpose only we designed that microfluidic center. Also.
Thank you very much, sir. As most of our students are working with all these pathogens, we request for more collaboration from your side, sir.
Definitely.
I request. Yes, ma'am. Thank you very much, sir. And it's time for registration of the lead speakers. Hema ma'am, for Hema ma'am, we'll be handing over. And on behalf of Dr. Jagdishwar sir, I request one of the scientists from BJPSU may take the members. Dr. Sudhakar sir is here. Sir, kindly accept our Vishwa sir, kindly accept our small token of break for tea sharply for 10 minutes.
Again, I just want to put it once again. I'm sorry if I'm harsh in the beginning, but it is coming out of, let's say, desperation or Bharata Kodindan, not aiming at any one individual specifically. Right? I hope you understand.
It is not harsh because we have the eminent scientists like Krishna Reddy and Dr. Ramil sir, because we are fortunate to have the type of encouragement from the seniors. We will break for tea for 10 minutes and then we'll start with the oral presentations. Those who are presenting online, kindly come back after 10 minutes sharply.
PF members కూడా. మనం మళ్ళీ లెటర్ పెట్టాలి. కంట్రోలర్ ఆఫీస్ వల్లే PF members లో అది యాడ్ చేయాలి. అదే రాసింటే మనం మళ్ళీ ఫైల్ పెట్టాలి. మేడం దగ్గర నుంచి ఫైల్ ఒకసారి రావా పెట్టేసి దానికి ఇది అర్జెంట్ గా మేడంతో సైన్ పెట్టుకోవాలి. టెక్నికల్ కమిటీ నేను మళ్ళీ పెట్టి డ్రాఫ్ట్ కూడా పెట్టి కావాలి. మళ్ళీ డ్రాఫ్ట్ వాళ్ళు అర్జెంట్ అన్నా ఇల్లు పెట్టాలి కాదు, ఏదైనా ఫైల్ పెట్టాలి. అవును.
Welcome back. We will start oral presentations in session 3. There are 4 presentations, sir, in session 3. The first oral presentation is on drone technology in agriculture, standard operating procedures for plant protection solutions in groundnut by V. Divya. Divya?
Madam, is it audible?
Yes.
Yeah, very good morning, all. Josna ma'am, is it audible?
Yes, it is audible and the slides are visible. Kindly put it on slideshow.
Okay. So, very good afternoon to all. So, I am going to present the drone technology and agriculture standard operating procedures for plant protection solutions in groundnut. So, we have conducted standard operating procedures in groundnut for 2 years at RARS Palem. PGT SAU. So the main objective is to standardize the protocols in groundnut by using drones. So for this we have used
please put it in slideshow mode.
slideshow only, ma'am. I kept in slideshow only. So whether slides are moving or not, ma'am?
No, not moving. Full screen. You unshare and share again.
Okay, ma'am. Is it okay, ma'am?
No. You have to make it full screen. So first open your presentation in full screen mode and then share your screen.
Yeah, ma'am. I kept in full screen mode only. Maybe due to network.
Before sharing, you have to put it in.
Okay.
Can you click view button?
Slides are moving, ma'am.
No, slides are not moving. On view mode.
Can you click on view mode?
1 minute, ma'am.
No, not really. Zoom. Keep side by side mode.
1 minute, ma'am. Again.
View options really side by side mode button. Or else you can share your PPT. Okay, we'll project your PPT from here. Divya, we have your PPT.
Yeah, ma'am. Actually, for me, it is opened and it is coming in slideshow mode only.
It's okay. Your colleague has given your PPT, so we will be screening from here. You can talk.
Okay, ma'am. PPT. Shall I start, ma'am? Ma'am, am I audible, ma'am?